Okay, so if I give you a set of zeros and ask you to write the function for that, you should be able to. Okay, so let's say I tell you the zeros are -1, 5, and 6. Okay, what factor corresponds with a 0 at -1? X minus a -1, so plus 1. What factor corresponds to an x or a 0 at 5? X minus 5. And then for the 0 at 6, x minus 6. So here is your function. And what can we do in our calculators to write this from this form into a polynomial? Expand. So we're going to use the expand command, F2, algebra tab, number 3. And then we're just going to type in those factors. X plus 1, x minus 5, and x minus 6. Close it off. And when you do that, you get your solution, x cubed minus 10x squared plus 19x plus 30. Write it in a function notation. And so here is the function that has the following zeros, the -1, 5, and 6. And now the directions for each question will also say, this isn't the only one for which this works, but it'll tell you that the leading coefficient is a 1. Because you could multiply every one of these terms by the same number and still have those zeros. And so for all of these, your leading coefficient will be a 1. Okay. When your zeros are all real numbers, there shouldn't be any problem. You guys should be able to do that. Again, it is a conversion or interpretation at first. However, if you have a 0 that includes an I, then it becomes a little more challenging. And what if your zeros were -2, 3i, and -3i? Okay, see if you can come up with a polynomial expression for that function, please. Okay, so if you identify the factors that correspond with these, what factor corresponds with the 0 at -2? X plus 2. What about 3i? X minus 3i, and then -3i. X minus a negative, so plus 3i. So here is your function. And once again, when you expand it, you can just enter your factors. So x plus 2. X minus, do you guys know where the I is? Okay, so it's right above the catalog. Okay, and then x plus 3i. Close it off. And when you hit enter, you get your function. X cubed plus 2x squared plus 9x plus 18. Okay, not too bad. Are there questions about these? These are the two simple ones, kind of the simplest and then pretty simple. There's one last one that's a little more tricky. So are there questions on these simple ones first? Sabra?
So if it was just, like, let's say it was the last problem where it was -5 square root I, would you just enter expand -square root 5I?
It would be x minus a negative, so x plus square root 5i.
Okay.
Okay, so the question is, what if the zeros had a radical? Let's do an example of that. So what if your zeros were, let's say 3 and then root 2i?
Yeah.
All right. One of the things that you have to keep in mind is imaginary zeros come in pairs. They're called conjugate pairs. And the conjugate pair means if you have a positive I as a solution, its opposite will also be a solution. So if I just told you, write the function for for zeros at 3 and root 2i. Okay? The fact that you have this I by itself means that its opposite, negative root 2i, even if I didn't include it, and which I won't when I give you a quiz on this, you have to include that on your own. Okay? Everybody catch that? Make sure you're not doing something else. Okay, this is the one challenging thing that you have to be able to do on your own. Your calculator won't do it. You have to understand any I or imaginary zeros have to appear in conjugate pairs. So if one appears, its opposite will also be a 0 for that polynomial. Okay, so if this was the problem here, again, we would set up our function as what factor corresponds with a 0 at 3? Minus 3. And at root 2i, x minus root 2i. And its conjugate pair, which is going to just be the opposite sign between. And now you can still expand it. Everything should still work as you were here. Write in your factors, including any radicals. Just make sure you put your I outside of the radical.
So are you always going to do the opposite? Like if it gives you 3, you're going to do minus 3?
Yeah. You always need to include the opposite of whatever zeros are given. So this gives you your final equation, x cubed minus 3x squared plus 2x minus 6. And so this would be your polynomial. All right, so last one, and then I'll let you have the last few minutes here to work on anything that you need to do. So see if you can write the polynomial function given these zeros. One of the things that you might want to do is think right away, what is the power or degree of your polynomial going to be? When we look here, 1, 2, because it's an I, we have to add another one. So 3, you expect your power to be 3. What do you expect your power to be for this function? We have one real 0. We have 2 different imaginary zeros, which each one has a conjugate pair. So it should be 5. So anticipate you should have a power of 5, or a degree of 5 for your polynomial on that. And again, if you just add your conjugate, your opposites here, so negative 3i and a positive root 5i, it should help you as far as determining. Locate the factors for each of these. Negative 2 has a corresponding factor of x plus 2, x minus 3i, and I'm just going to put its conjugate pair next to it, x plus 3i, just same term, opposite sign between. And then I have my x minus a negative, so plus root 5i times x, again, same terms, opposite sign between, so x minus root 5i. And if I expanded those out, multiplied them, I'd get my final function. So if I expand those, just type in my factors. Close it all off. And when I do, it's what I expect. The highest power is a 5. So x to the fifth plus 2x to the fourth. Okay, again, you have to extend the display. And so this would be the function that gives you, or that can be created using those given zeros.